a platform where you can run applications, and you can distribute them, and you can build them, and you can move them around. It leverages container technology on Linux and other platforms, and it's the primary method of communicating those applications is something called an image. So an image is simply it's like a runnable component with a file system, to put it simply. So containers, effectively the runtime of Docker, is where you run your applications in Docker, are created from images. The file systems of that runnable component is made up with layers, and they're just tar files. And then you take these tar files and you layer them on top of each other, so you can build up the file system. And part of that image specification is a description of organizing those layers into the image. So it says, image A goes above image B, goes above layer C, and so on. These images are identified by name, like Ubuntu or Redis or Stevu/myapp. And so when you run something like Docker run Ubuntu in Docker, this runs a container created from the image Ubuntu. So what we're here to talk about today is moving these images around. And the classic way that we've done that in Docker since its release is a registry. So what is a Docker registry? It's a central place to store and distribute Docker images. So what does that mean? It basically just stores the layers and the description of how they make up an image. Typically, it implements a common API agreed upon by Docker clients, and several implementations can exist, such as like just a simple web server making the content available. It could be a complete web application, like we'll talk about a little bit today. And services like the Docker Hub contain a registry. You can read about the documentation at the link I've provided there. So we'll jump right into it. We'll go a little bit over the history of the API for version 1. If you have questions, just drop them in the chat below, and we'll take care of them at the end. So this might come a little bit fast. So the current Docker Registry API, or version 1, is layer-oriented. Each layer is referenced with like a randomly assigned ID and that's part of the registry. So each registry that you have might have a different ID for each layer, depending on when it was assigned and how it was assigned. It's completely random. And then we have a JSON object corresponding to each layer, referencing a parent. And then we name our images through something called tags, effectively. And if we look at the diagram here, we can see the layout of a V1 image. We have kind of a fetch operation which uses an ID to grab a JSON object, and that JSON object references a layer ID as well as a parent. And so you can see the fetch model is you fetch one layer, and then you fetch its parent, and you fetch that layer's parent, and you fetch that layer's parent. So you have to do all of those round trips inside of the V1 API. Don't worry too much about this, but this is the V1 API layout for reference. Notice that there's similar API methods for layer and JSON, as well as a tag API that can be used to manipulate and add new tags to each image. The interesting point here is there's also an ancestry endpoint which was added to deal with some of the problems with having to do like a linked list fetch to grab V1 images. You can read about the registry API at the link at the bottom here, but you can just use this slide for reference later if you go back over this talk when we make the slides available. So what are the problems with the V1 API? Like, why are we even sitting here talking about this? The biggest one is this fetch a layer, fetch the parent, fetch the parent, fetch the parent, fetch the parent. It's slow, and it's kind of a single track. The ancestry API does deal with that, but to build that ancestry, you still need to walk that linked list of layers. The other big aspect of the V1 API is the security. So for instance, the image IDs are really a secret. Not only are they unique to the registry that you're pushing your images to, but you can't be sure of who assigned your layer ID. So if you push it to one registry, the layers might have different IDs than another registry. This is really hard to audit. It's hard to verify, and isn't a great base on which to build a content distribution system. Another aspect is that the implementation is in Python. So I love Python, and I've scaled Python to great lengths. But if you're a Ruby developer running a Python registry, if you anything Ruby, Node.js, Java, Shop, running a Python registry and getting that to scale out can be a problem. So it greatly affects the ease of deployment in the registry versus having something like just a binary that you can ship around. The other aspect is that there's reduced code sharing with the main Docker project. We'll see later on why this is really important, and I can talk a little bit about the effects that it's going to have for the future of image distribution. There's more information available at issue 8093, and that will cover some of the information about that's the original kind of V2 or let's do V2 proposal. So it might be interesting background to read. So we'll jump right into the design of the Docker version 2 of the Docker Registry API. So first of all, the goals, we started out and said, okay, well, we want it to be simple. It should be easy to implement. You should be able to define a static host that can serve it up. We'd like to separate the location of content from the naming so that you can move it around and not have to worry about where you're getting names and identifiers from. Security-wise, we wanted verifiable images and straightforward access control. And we wanted a protocol that could be implemented in a much more performant manner and remove the single track that I talked about with the V1 layer layout. And we also wanted to move to Go to increase the code sharing with the Docker engine. And some might think that's a performance thing, but having some common code between between Docker and the registry is a huge win as far as keeping everything interoperable. So the first thing we said with the V2 API was to make layers content addressable. Layers are just treated as blobs that you can, and you can reference those blobs with a content address. This is much, much better for security. It permits safe distribution through untrusted channels. So I can send you a piece of data and a hash, and then you can ensure that that data hasn't been tampered by making that hash calculation yourself. And the other aspect is since we are content addressing content, the data is immutable, so it improves the cacheability by quite and makes caching a lot easier. We haven't leveraged all the cacheability yet, but we will in the future. So this content address is known as a digest. So what is a digest? It uniquely identifies content. It's a cryptographically strong hash. We chose the digest name so it doesn't conflict with like hash, map, dict, so that we don't have that confusion. You just have digest. It's not commonly used. It's for message digest, but it's just a hash. It's just and for registry V2 we've made it really simple. It's just a SHA-256 with the bytes. It's very, very easy to implement. It's easy to verify, and it's very, very hard to get wrong. So implementing a client, it doesn't require a wildly complex hashing algorithm that might not be available in certain client languages. As I stated before, in the goals, it's independently verifiable. If you and I agree on a common algorithm, we can choose IDs for content without coordinating other than choosing the algorithm. And one big aspect of it is we made a strongly typed library for the digest with tools to parse and verify it so that people aren't dropping random verifications and random hashes and doing odd things in the code. It's just import digest package, and you can parse and verify it to your heart's content. The other concept in the V2 API is a manifest. Now, if you remember the slide before, there was several JSON objects for each layer. The manifest effectively takes all those JSON objects and puts them into a single object that we can fetch by an ID. This allows the V2 protocol users to immediately fetch all of the layers in parallel. So it's much faster in that regard. The manifests are content addressable as well. And what does this mean? You can run this Docker pull Ubuntu command with that digest, and it will ensure that you have the exact same image that I have on my laptop. I pulled this last night and dropped this in the slide, and you can run that exact same image and be assured that it is identical to the one that you're running just by using that digest. These are leveraging something called a Merkle DAG, and the concept is simple. Because the digests of the layers are in the manifest, if any bit in the layer changes, the digest of the manifest also changes. You can read up on Merkle DAGs on your own. There's lots of interesting literature, but it's like similar to how Git and IPFS, Camly Store, and a host of other projects all ensure content it hasn't been changed. The other aspect is tags are in the manifest. This will probably go away in the future as we move away from V1. So on our next slide, we have a small overview. I've left out some fields for brevity, but we have the important parts of the manifest. It's just a name tag, a list of file system layers, and then we actually keep the original V1 JSON object that I covered in an earlier slide in a field called history, and that's just a list of the layers and how to build them, and it ensures compatibility. We can have V2 support within Docker itself, but not have to change the internals of Docker quite yet, because we're still working on that. So now in registry V2, we've still retained the concept of repositories, except all content is now part of a named repository. So if you looked at the API before, you'd notice that image IDs can be fetched by IDs, and there's not really much access control in the URL layout. What does this mean for V2? It means that image IDs are no longer a secret. You cannot access them if you do not have access to a repository. We've also simplified the authorization model. So all you need to do is ask the question, do you have access to the name plus this operation, whether it's like push pull, or we have some admin support as well. And no round trips are required when using token off, actually. So it's all inside of the registry. This was a performance problem in the V1 registry. It also makes the implementation a lot more simple and more secure. And so clients move content into a repository by proving they have it, by providing it. Another aspect, I'll cover some interesting aspects of that later. We opened up the namespaces to allow more than one component. So there's no reason to have the registry enforce user/image. We wanted to open that up and make that more of a convention. We also reversed the API to make static layout easier. I'll gloss over this slide, but these are some other aspects we considered in the API V2 design, as well as the implementation of the registry. For instance, there's shared nothing. The back end is tying the registries together. It's pull optimized, so the most important factor when distributing software is pulls, and this can hurt certain use cases. And we have resumable push and pull support, but as part of the specification, it's not implemented due to some work we're doing in the client, but the registry is already supporting resumable pull by supporting HTTP range requests. So you can write a client that can do that today. And really the specification is living. It's meant to be used and modified and always be backwards compatible. But the main point here is that rather than having to a scattered base of documents and stuff to gather up to work from, we can kind of work from this specification and use it as a platform to make design proposals from. So here's the URL layout. The main differences are, of course, the content addresses are the primary identifiers that's used with both blobs, and what we have on here is called a reference. So you can get a manifest by its tag or a reference. And this is very different from the V1 API. The other aspect of this API is that there's a multi-step upload process. You actually initiate a post to the uploads endpoint, and then you can, it will actually give you back a location. You don't even calculate the last URL on the slide. And then you can issue gets, puts, and patches and deletes to carry out that upload. So right now, we don't have a search API. This API was kind of all-encompassing in V1, and we had reservations about that, and we are going to replace it with something better that can aggregate across registries throughout an organization. And there's also no explicit tagging API. We have a proposal out for that to kind of integrate better with the content addressable nature. So let's dive into the implementation a little bit, and I can tell you, we released Registry 2.0 with Docker 1.6. It's mostly a success. You can go take a peek at it at the Docker distribution project on GitHub. It is now running the hub. It's an S3 backend. We are having a little trouble with round trips to S3, and I know some users have had this issue, but we're working on it. The interesting aspect here, though, is the V1 registry does heavy caching, and we are doing almost no caching, and the performance is standable. Nobody's been complaining about, especially pull performance. We can talk about push performance in the next slides in relation to Docker. There's still a lot of low-hanging fruit left to tackle. So with Registry V2, if you're using it now, just continuing with the upgrade path, it's just going to get faster and faster. So we have full support for V2 with Docker 1.6. We have minimal bugs, and most of the problems seem to be around that are common diversion upgrades. There's a header that can make auth support a little bit tricky when running through a proxy if you're looking to do basic auth. So most of the concepts were validated in 1.3 and 1.4 with the V2 preview. So you've probably already seen much faster pull performance from the official with official images on the hub. And there are some edge cases. So anything that's push heavy, there's a few caveats. I won't go too deeply into those. If you're curious, you can hit me up on IRC or send a mailing list, and I can cover them. And then as well as the disk I/O when verifying large images. These were somewhat foreseen and part of the poll optimization. So we're working on mitigating these right now. But if you have those cases, you may be affected. Again, I would try it out. So the question you may be asking is, should you be using the registry currently, or the 2.0 registry rather? So if you're on Docker 1.6 plus, or you're just considering deploying Docker into your data center or cloud or what have you, you should absolutely be considering the use of the V2 registry. Evaluate it, test it, break it, let us know about bugs, and go ahead and deploy it, and you should be okay. We've been running it in production for several months now without issues, and it's fairly stable for the age of software that it is. So if you're on 1.6 or less, if you're already entrenched in V1, you might want to hold off. There are some migration solutions. You can run dual stack where images, where you can kind of segment V2 and V1 images. You do if you push with 1.6 and then you have like 1.4 clients, and you're pushing to a V2 registry with 1.6, they might not be available. So we don't some people have asked to be able to port V2 and V1 images back and forth, but I'd recommend not attempting to do that. There's a lot of problems with keeping that data in sync, and it's a lot of operational effort that probably won't be worth it in the long run. You can get more information at that link and through the project. You can either ask questions on the mailing list if you're curious. So deploying the registry right now, I would recommend using the Filesystem driver. It is really, really, really fast. Like if I do the Filesystem driver with Redis, it's actually slower. So Filesystem driver is just fantastically fast. And then you can back up your data with rsync. Because we wrote the backend storage layout to be consistent on eventually consistent backends, backing up with you can just snapshot it any time, and you'll get a consistent view of what's in the registry. And if you get a half operation, it'll just be when that operation completes, it'll pick up the new data on the next rsync. If you're looking to scale out storage, I'd recommend using the S3 driver. Make sure you're close, since the round trip times can have an effect. And what I mean by close is, a decent round trip time to S3, like 100 to 200 milliseconds seems to be the limit of performance there. This won't be true any longer once we add in more aggressive caching of small blob objects. So if you're looking to scale reads, where you have a small set of data that'll sit on a single machine, you can use round robin DNS to distribute users of the registry out to multiple followers on a read-only file system, and then you can just add machines to taste. So basically, you'd have like a registry root, and you'd push to that, and then you could just rsync out to the followers, and that'll let you arbitrarily scale reads. Make sure you set those file systems to read only. That's not an option we have in the registry. You also use like chmod and users to get that to work. You can read all about deploying at the link here with the documentation. There's lots of information there. If there's something missing or something you expect there, please do file issues. We're still working on getting the docs up to snuff, and hopefully those will be adequate for your use case. So what are we doing in the future? Right now, we're really focusing on maturity and building collective operational knowledge around the registry. There's some bad practices from V1 that I won't go into that we need to break. And that's just working with people and figuring out what was really needed in V1 and what do we actually need to bring into V2. The big one is proxy caching, so the ability to point your registry at an upstream, say the hub, and pull images from there and have the registry cache. That's going to be coming soon. There's also a catalog API proposal that I'm working on that answers the question, hey, what's in my registry? And the other big one is deletes. There's a whole bunch of information that you can read about deletes in the Docker distribution project as well as Docker itself. But the current state is that diverse backend support makes this really hard. We're looking for a way to make this easier and at the same time keep deployment of the registry, of the 2.0 registry, just as simple as configuring a backend in a cache location. So look out for that. We've also will be looking into a search implementation, and I can go into this a little bit when we go over the goals of Docker distribution project. So you might have noticed all the GitHub links include a project called Docker/distribution, and you must be saying, well, that's not the registry. So the Docker distribution is a project to improve like the packing, shipping, storing, and delivery of content within the Docker ecosystem. The goals are to improve the state of image distribution, make it better, easier to use. Our focus is going to be on security, reliability, and performance. And really, we want to build a solid and secure foundation on which to build other distribution models. Like, for instance, moving images around should no longer require a registry. You should be able to SSH images around or use like peer-to-peer networks for large deployments. A lot of this work in the Docker distribution project is opening this up in the Docker daemon so that we can actually unlock these new models. What are we doing in the near future? Right now, we are really working hard to clean up the Docker daemon code base, push and pull code base. We've defined a lot of new APIs for working with Docker content, and our goal is to increase feature velocity, and we have to some degree, and then be able to generalize around a strong base. So, we built this model up on blogs and digests, and it really, in content addresses, and it really lets you have a strong system to reason about moving that content around. So the other thing that's big in the near term that's Docker-wide is the current manifest format is really provisional. As I showed in the earlier slides, it still includes the v1 layer JSON. And the nice thing is we want to move everything to content addressability and use media types to make supporting new formats really trivial. And once we get that in, we can start iterating on the manifest format and get something that's really solid and will decouple enough from the application runtime and the dependency expression such that the two can develop without having to be dependent on each other. You can check out pull request 62 on Docker distribution for that work. No, this really isn't an image specification yet, but this is something that we're looking into, and it's part of that effort. You can check out the roadmap on the wiki. That link's available at the bottom here. So a little bit of information about the Docker distribution project. So you can contact us at the Google group distribution@dockerproject.org. Our GitHub, as I've sprinkled throughout this presentation, and I've repeated here again, is docker/distribution. And you can also contact us on Freenode via IRC at hashtag Docker-distribution. Also, I recommend that you come and join us at DockerCon, and it's in June in San Francisco at the end of June, and you can register now and get a 10% discount. So with that code, it's contain yourself, which is fun to say. So now I'll be concluding and be taking some questions. Yeah, I can't see that. Hold on, I have to be able to see the questions. All right, so the first question that I'll be covering is the digest a hash or is it metadata? And further on, Praveen asks, can you explain the hierarchy, like layers, digest, manifest, as to what is a subset of what? So a digest is just a hash of the content. You can associate metadata with that hash, but that's really a separate object. The hash, the digest is just a SHA-256 hash for the most part. Now the hierarchy is pretty simple. So a manifest contains a list of layered digests. And then when you take the nothing's really part of the question was, what is a subset of what? And nothing's really a subset of any, I guess digests are a subset of manifests, but you can also have, but digests are really a property of an object or a thing, right? So when you have a set of layers, you can take the digest of that list of layers. That's effectively what the manifest is. So imagine if you concatenated all the layers together and you took a digest, you took a hash of all that. It's roughly equivalent for the purposes of working with a Merkle DAG to just take all of the hashes and concatenate them together, and then take the hash of that to uniquely identify the set of content. So Greg Edwards has asked, what does it mean that clients prove by providing data? So this is so basically, rather than trying to have access controls, like this person has this blob, owns this blob hash, and this person owns that blob hash. Each repository is self-contained, and when you want to move a piece of data from one repository to the other, you need to push that data into the repository. What actually happens on the registry side is it verifies that data and then drops it on the floor. But it's ensured that you, who have access to that particular piece of data, can have actually proven it to the registry, and then now that is it's now a member of that repository. The next question, again from Greg Edwards, is asking, what does it mean there's no tagging API? Can you still tag a repo and push it, pull it from, and get that? Can you still tag a repo and push it and pull it from a repo 2.0 and get that specific tagged image? Yes, absolutely. You can do all of those things, and they're a big part of the V2 API. The big difference is that there's no explicit tagging endpoints, but as I pointed out at the end of that slide, there's already a proposal to add explicit tagging endpoints, and we're also defining a new manifest format that doesn't have an embedded tag like the current V2 format. Greg Edwards asked, is there any way to, on 2.0, to find out what images tags are in a repo? Again, I covered this earlier in the presentation. There's a tag list API that will tell you which tags are in a repo. If you want to know which, and that's probably the best way to figure out which images are in your repo. So I'm not sure how that sounded like now. We can figure that out. Another person asks, looks like they've had some problems with timeouts against the registry and with polls, and they're asking where should that be reported. It's okay anywhere. So either the issues tracker on Docker distribution or the Google groups is appropriate to report those kinds of issues, and we'll try and help you figure out what the problems might be in that area. Another question. So yeah, will Registry 2.0 address delete images and orphaned unreferenced layers cleanups with a S3 backend? This is a great question. There's two slides there's a slide where I talked about deletes, and there's two issues on there. And we separated the deletion problem into two aspects. And this question is specifically referencing the S3 backend. Now, the reason we've separated this into two aspects is because there's two use cases really. There's data cleanup, which is what this person's asking about, and then the other is data access. Now, we basically said, okay, well, we can separate these into two problems and solve them into cover each use case. Just deleting stuff is is very easy because you can just drop tombstone files. There are some performance aspects of it. Then the other aspect is cleaning up unreferenced layers. Unfortunately, S3 is not consistent, so making decisions about deletions without some sort of locking system on top of that is very, very dangerous. We do care about your data, and we will not push a deletion solution until we have a solid way of ensuring that when we do delete images, that the right data will be deleted and not the data that you don't want to be deleted. Is Docker distribution for storing and sharing images only, or can it also be used for storing application data? So yeah, it's interesting you asked that. Yes, it will. If you fire up a registry right now and you drop some data in there, it will store application data. Do I recommend people build something on that? Give it a try and see what happens, but be fairly certain that you may run into bugs. We'd like it to be able to store arbitrary application data, but it is designed for storing and sharing images. So the answer is yes. The next question is it good for I/O or is it worm-based? So I'm going to assume that you mean that it's poll optimized, so worm optimized, but you can write it should scale with I/O on push at the registry side at least. So don't worry about pushing your images over and over again. If your images do change, they will get pushed, and there is a good amount of I/O available. But it's not strict. I wouldn't strictly use the term worms here. The next question is, will Registry 2.0 support previous Docker client versions, or are we forced to upgrade our clients for support? No. So right now there's no plan to support previous client versions. As I kind of indicated, if you're in an environment where you really can't upgrade your clients, I'd recommend staying on V1 for now. There's a lot of security problems with the V1 protocol, and we don't really want to bring that into the V2 code base. There is a possibility of making like a translating proxy that can translate for V1 and V2, but we have no roadmap for that, nor do we have bandwidth for that on our team yet. So the next question is, can you integrate SHA-256-SUM into the pull request with a tool like curl to verify that a man-in-the-middle attack didn't change your code? Yeah, so we're already somewhat doing that. So I don't know if there's an existing tool, but like let's say you curled a layer, you could key that into something like like a SHA-SUM calculator, and then key the other one into an output file, and that SHA-256 outputted should match the URL hash that you put or the Docker content digest header in the HTTP response. So the next question is, does the digest or does the content addressability of layers make layers a great candidate for a P2P distribution model? The answer is absolutely, and this is part of our future work. And the big impedance right now is getting the Docker engine into a state where we can modify the code and ensure that it's robust enough, and there's some security avenue to make sure that when you are participating in P2P, you only take content and hashes from there, and not names or any other kind of security sensitive items. The next question is poll performance going to increase? Currently, it takes a long time to pull an image. So poll performance has increased. If you're having poll performance problems, I'd recommend bringing your issue to the Docker distribution mailing list, and we can see what your problem is. You might have a slow pipe, or there could be an issue with your configuration or setup. We can look into that directly. And the last question on here is, what about using other non-Amazon S3 object stores that are S3 protocol compliant? So there is currently a PR that does cover. It's adding, I think it's Aliyun OSS, which is I believe Alibaba's S3 offering. Unfortunately, the PR takes most of the coding, copies it over from S3. We'd actually like to modify the S3 driver to be able to directly use these S3 compliant storage backends. Will they work with some? They'll probably work with some massaging, but we haven't looked into it. I assume somebody will have a need and has a lot more expertise on these other kinds of object stores. Will be able to at least guide us in that direction. If you're looking for that, please take a peek at the issues list on GitHub, and there's a few issues on it. Or go ahead and file a new one and see if you can advise or point us towards somebody who can advise and ensure that we can get something so that people can use that. It should be more than possible though, and not with months of work, but a very short time. All right, so I think that's all the questions we have for today. Thanks for attending this meetup, and it was great to have a chance to talk to you all. And I hope I provided some interesting background and knowledge on the registry. Thank you.